Good morning, my YouTube viewers. It's Crystal here. I'm here this morning to give you another code review, and I'm going to have to make it quick because I have to leave to go to my day job soon. But what I wanted to do is I wanted to forecast the price of Bitcoin using linear regression. And last night I was just thinking, well, what would the outcome be if I use linear regression to forecast Bitcoin? So that's what we're going to do. And then we're going to go through the code, which is in Python. And I used Jupyter Note, used Google Colab to make the program, which is a free online Jupyter Notebook hosted by Google. So the first thing that we do after we create the Jupyter Notebook is we import the libraries. So we're going to import pandas to create the data frame and process the data. We're going to import NumPy to create NumPy arrays and perform numerical computations. We're going to import datetime to timestamp the dates. We're going to import math to perform mathematical computations. We're going to import sklearn to provide machine learning functionality. We're going to import matplotlib to um, visualize the data, and then we're going to import Seaborn to statistically visualize the data. So the first thing that we do after we've imported our libraries is we're going to use pandas to actually read the CSV file into the program and convert it into a data frame. So I think that I got the Bitcoin prices from something called CoinCode, but I can't show that to you because I'm using a free video recorder, free screen recorder, and it will only allow me to video one tab. But I think it was CoinCode that I used to get the Bitcoin data, download it, save it onto my Google Drive. So that's where you can get the data to download and save onto your Google Drive. And then I converted it into a data frame where it has start, end, open, high, low, close, volume, market cap. And then we check the info. You see that the first two columns are objects and the rest of the columns are numeric. So you can see what type of data frame it is. We check for any null values. We don't have any null values, which is good, so we don't have anything to impute. If we did impute null values, then you would have to use pandas to impute the null values, and that's one thing that you would have to do to impute the null values for our time series. Now what we're going to do is we're going to timestamp the end column because that's going to be the date that we're going to use. And after we have timestamped the date column, we're going to set our features up as end and close. Those are the two features that we're going to use. And then we're going to create a new data frame with that, with just end and close. So now what we're going to do is we're going to use matplotlib to visualize the data, and you can see here that what we're going to do is we visualize it from 2021 to 2024, and you can see 2024, it has the highest prices. I used Seaborn to create a histogram so you can see the distribution, and this is the histogram that was made using Seaborn. So now what we're going to do is we're just going to plot the 2023 so you can see what it looks like, the prices look like in 2023. And then after we plotted 2023, we're going to plot October to December 2023. So again, you can see what the prices look like October to December 2023. So now we're going to use stats models to seasonal decompose the time series data, and we're going to use multiplicative and additive. So if you love statistics, then you can use stats models to seasonal decompose your time series data, and then that way you can study it. So you get your seasonal multiplicative decompose, you check your trend, you check your season, and then you check your residuals. And so if you want to study that, you're more than welcome to study that. And then we use additive decompose, where you've got your trend, your seasonal, and then also your residual. So now, after we've done our decompose, and you can study that on your own if you're really interested in studying the exact mechanics of the time series, we're going to extract the features. So we're going to take the end, and we're going to get the year, the month, the day of the week, and the weekday names. We're going to set it up as features, and we're going to create a new data frame. And this is the data frame, the printout of the data frame that it looks like. So we're going to do a box plot now so you can see what each month looks like. So here you go. You can see each month of the box plot, and you can see you have most of the traffic in, I think, April, or the highest amount of traffic in April. And now we're going to check a box plot for the year. And you can see that we've got the highest amount of traffic in 2024, the highest prices. Now we're going to check the box plot for the day of the week, and you see that those are very similar, just very mild changes. Now we're going to resample the time, so you're going to check what it is at the end of the year. So this is what the bar chart looks like at the end of the year, and you can see that 2024 has the greatest prices. And now we're going to check the beginning of the year, and you see again 2024 still has the greatest prices. Now we're going to check the monthly, and you can see it tells you what the prices are every month during the period that we are checking. And you can see that that looks pretty high too. Now what we're going to do is we're going to do rolling. And what rolling does is rolling just kind of like smooths out the time series. It wouldn't allow me to roll it as a 0. So I just had to roll it as a 1. And then I rolled it as a 30 to smooth it out so you can see what it looks like smoothed out. Again, that's a good analysis. If you really want to study analyzing time series, that's a good thing to look at. Now we're going to go into the machine learning portion of it. We're going to make a new data frame called MLBTC, and we're going to use the features end and close. End is going to be your index. So you can see right here we've got end and close, and that's your data frame. And it's a univariate time series. And now what we're going to do is we're going to reverse it. The reason why that we're reversing it is because you need to have the earliest date at position 0 and the latest date at the end of the data frame. So now what we're going to do is we're going to set up the define train plan, which is going to be 80% of the length of MLBTC. And we're going to define our train data as being 0 all the way up to train len, and val data as being train len all the way to the end. And then you can print that. You can print your shape, so you make sure that you got your shape right. So we check val data just to make sure that we've got that, because that's what we're going to be using. And as you can see, the earliest date is at position 0, and the latest date is going to be at the end. Okay, so now what we're going to do is we're going to scale the data from 0 to 1. And we're going to use sklearn's min-max scaler to do that. We're going to scale the train set and also the validation set. So now what we're going to do is we're going to set up our X train and our Y train, and we're going to use that as a range of 50 to the length of scale train. And we're going to do that because we have to make the time series a supervised learning example. We're going to do exactly the same thing to the validation set. We're going to set up our X val and our Y val, and you have to, again, it's going to be done exactly the same that you did it with the train set. Okay, now what we're going to do is we're going to take X train and X val and convert those to data frames using pandas, and we're going to take Y train and Y val, convert those to series using pandas, and then you can check the shape of these data sets. Now, what we're going to do is we're going to use linear regression, sklearn's linear regression, and I got a 99% accuracy using sklearn's linear regression, which was higher accuracy than we had when we were using the MLP regressor. So now what we're going to do after we have trained the data into the model, we're going to predict on the validation set. And so you're going to get your Y-pred. And then after we predicted on the validation set, what we have to do is we have to reverse scale the validation set and set it back up to the original values. And then we're going to reverse scale the predictions and set them up to the values that they would have been if the data hadn't been scaled. And then, so now what we're going to check the RMSC. I was absolutely gobsmacked to find this out. RMSC is 1608, so that is significantly less than the RMSC in the deep learning networks that I was using and the RMSC in sklearn's neural network. So this is the best error that I've had so far studying this. So another thing that you can do is you can make a data frame to show the actual values and the predicted values so you can see how they compare. And what I've done is I've used Matplotlib to superimpose the actual values across the predicted values, and you can see the actual values are quite close to the predicted values. And then I used Matplotlib to superimpose the predicted values against the actual values, and this is the time series mechanism that was printed up. And I have to say that I was quite gobsmacked that the predicted values were so close to the actual values. And so what that tells you is whenever you're studying a time series analysis, you need to use all kinds of different models and see which model's the best. So linear regression might not be the best model to use in every data set, but obviously it was the best model to use in this data set because you had a really low error and the predictions matched up very closely to the actual values. So I was quite shocked. I did not expect to get a good reading on linear regression. Linear regression is one of the simplest models to use. And so I'm quite quite pleased with the result. So I'm going to go ahead and close this video because I've covered all of the information that I would like to cover. But I would like to thank my subscribers for supporting my channel. If you like this video, please like and subscribe. And I look forward to communicating with you in the next video.